So this is the 2016 Junior Cert Higher Level Paper 2, and we're looking at question number 2. Paul is raising money for a charity in his school. He organises a fun day where one of the games is played using the spinners and the rules shown below. So here we have spinner A, the value is 1 to 3, and spinner B, the values of 1 to 5. So the rules of the game: you pay €1 to play the game, which means spinning both spinners. You get the same number on both spinners. If you get the same number on both spinners, you get €1 back, so you get your money back. If you get a sum of 8 on the two spinners, you get €8 back. So part A says, complete the two-way table to show the sum of the numbers on the two spinners. So we can see here's the two-way table, spinner B across the top spinner A. So for example, if you get 1 on spinner A and 3 on spinner B, you add the 1 and the 3 to give you the 4. So I'm just going to fill in the rest of the values. 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 4 is 5, 6, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, 6, 7, and here we have 1 plus 3 is 4, this one's done, 3 and 3 is 6, 4 and 3 is 7, and 5 and 3 is 8. So that's our two-way table filled in. So each outcome in the two-way table is equally likely. Find the probability that you get €8 back if you play the game once. If we go back to our table, probability of getting €8 back means getting an 8. So the probability of that happening is just this value here. There's only one way you can get 8, that's by getting a 5 and a 3. So the probability of this happening, it's one chance out of a total of 15, because there's 3 rows of 5 here. So there's 15 outcomes altogether. So the probability is 1 over 15. Part C says 300 students play the game. Find the number of students you would expect to get €1 back. Okay, so we'll go back again to our table. €1 back means getting the same number on both spinners. So I'm going to highlight this in a different color. So the same number of both spinners, that's a 1 and a 1 to give a 2 and a 2 to give a 4, or a 3 and a 3 to give a 6. So you have 3 chances out of 15, 3 out of 15 chances of getting your money back, getting €1 back. So 3 out of 15 is the answer. That's the probability of getting your money back. Now, if 300 students play the game, well, you would expect that 3/15 of them would get their money back. So it's 3 over 15 multiplied by the number of students. The probability of getting the euro back multiplied by the number of students. And that gives us, on our calculator, 64. So that's the number of students you would expect to get €1 back. Part D says after 320 students have played the game, 74 students have got exactly €1 back, and Paul has made a profit of 110 from the game. Find the number of students who got €8 back. Okay, so let's see, if 320 students played the game, 74 got €1 back. So let's see the students left over then. 320 minus the 74, that leaves us 246. So there's 246 students that either got €8 back or they didn't get anything back. They just paid the euro to play. So we know that if Paul has made a profit of 110, all these students here paid €1. So let's see what's left over. If they all paid €1, that's €246. Let's take away the profit. That leaves us with 136. So that is the number 136 euros that must have been paid out in 8 euros to a number of people. So if we have 136 euro, 8 euro for each person, well, the number of people would be 136 divided by the 8. And on the calculator that gives us 17. So it's 17 students who got 8 euro back. Part E, Paul says that the probability of someone getting money back, 1 euro or 8 euro, would decrease if he changed spinner B so that it went from 1 to 6 instead of 1 to 5 and kept the rules the same. Is Paul correct? Make out a 2-way table using the change spinner B and use it to justify your answer fully. Okay, so we're going to have to do out a new table. So if you remember, there was the numbers, we're going to have the numbers 1, 2, 3, 4, 5 and 6 this time. Instead of 1 to 5, it's 1 to 6. And then right here we're going to have our 1, 2 and 3, spinner A. So there's A, there's B. So that's our table. So this is our table. We're going to fill in the values again now. So 1 and 1 is 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, and 4, 5, 6, 7, 8, 9. And they want to know is, Paul says the probability of someone getting money back, so that's, money back is the same, or 8 euro. So the chances of getting two the same are 1 and 1, 2 and 2, 3 and 3. And then there's also the chance of getting an 8, to get 8 euro back. So we can see there the probability of getting a 1 or 8, 1 euro or 8 euro, in this case is 1, 2, 3, 4, 5, and this time it's out of 3 rows of 6, so it's out of 18, so 5 out of 18. And if you remember from before, if we go back, the chance of getting numbers that are the same, a pair of 1s, a pair of 2s, a pair of 3s, or an 8, was 4 out of 15. So that's what we're comparing it to. So 4 out of 15, and we're comparing that to 5 out of 18. So the easiest way to compare is to express it as a decimal. So 5 out of 18, that gives us 0.27 recurring. And 4 out of 15, well, that gives us 0.26 recurring on our calculator. So we can see that the 0.27 recurring is greater than 0.26 recurring. So is Paul correct? The answer is, because they say, Paul says that the probability of getting money back would decrease. So we can see that actually it increases. So is Paul correct? No, he's not correct, and we've shown why. And that's the end of question 2.